we'll discuss the Bezier curves. At the beginning, we'll discuss the properties of the Bezier curves, and then we'll discuss the Bezier curves equations, and with the help of the equations, then we'll discuss how to draw a curve when some control points will be given. And I'll show you now some sample of the Bezier curves. Now you can see there are three control points are given: P0, P1 and P2. An expected curve is the solid lines. You can see this is the expected curve. Now I'll tell you some properties of the Bezier curve. You can see here the curve starts at the first control point and end in the last control points. That is the first property. Second property, you can see that at the starting, the slope of the curve is along the line joining the first control point and the next control point. And similarly, when the curve ends, it is also the slope of the curve is the last control line joining the last control point and the previous control points. And that is the second properties. Third property is that this curve will lies in the boundary if you join all the control points, and you will get a polygon, and this curve will be bounded by this polygon. And the fourth property is that it will require to the Bezier function to be discussed, and that I'll discuss later on. Now here you can see that I have considered this for three control points. Now you can see another example of expected curve of Bezier curve with the four control points, and you can see here P0, P1, P2 and P3 are the four control points, and in the solid lines, this is the expected Bezier curves. As already I discussed about the properties of the Bezier curve, here I have given on writings that Bezier curves connect the first and the last control point. Now this is the first property. Second property is that slope of the Bezier curve at the start is along the line joining the first two control points, and slope of the Bezier curve at the end is along the line joining the last two control points. And third property is that Bezier curve lies within the convex polygon boundary of the control points. And the fourth one, already I told, that requires to understand the Bezier equation, and that I'll discuss. But as a property, I can say that Bezier functions are all positives, and the sum of them is equal to 1. Now we'll discuss the Bezier curve equations. Here I am showing, suppose that x0, y0, z0 is the first control point, and the last control point is xn, yn and zn. In that way, we are getting the n plus 1 control points, and these n plus 1 control point can be denoted by a single notations. This is a pk, and here I wanted to mention the p is a small letter I am taking for control points, and subscript will vary from 0 to n, and in that way we are getting n plus 1 control points. And now suppose the Bezier polynomial functions between the first control point and the last control point is denoted by, here I wanted to mention here, it is a capital P, and u in the, here you can see u will vary from 0 to 1, that we are going to discuss. And therefore this capital P will be referring a point on the curve, Bezier curve. That is to be important thing to be mentioned. It is the capital P symbol is used for a point referring to a point on the curve itself, and small p, small letter p will be denoting to a control points. Next, this is the Bezier curve equations. Here you can see this is the Bezier curve equations that I'll explain in details. Here you can see this is the Bezier function. It's called a Bezier blending function, and here you will be varying from 0 to 1. And here already I told it is a small letter p and with a subscript k, and that is mentioning a control points coordinates. Here in a single equations we are denoting all the coordinates, x coordinates, y coordinate and z coordinate, and that I'll discuss in details in the next slide. Next, you can see the Bezier equation itself. This is the equation. This is the expansion of the Bezier functions, Bezier blending function. This is the expansion, and here you will be varying from, already I told you will be varying from 0 to 1. And here already I told this is an equation where x coordinate, y coordinate and z coordinate all are combined in the form it will shown. But if in the details you have to show, you would see that here we are showing the following three equation of the three individual coordinates. Now here, this is what does it means. This is the x coordinate of a point on the curve with a particular value of u, and to find that we have to use this expression, and it will be very clear when we take up an example. And exactly similarly, this is the y coordinate of that point with a particular value of u, and it can be found with this expression. Exactly similarly, for a z coordinate also we can found it can be found with these expressions, and therefore combining this is the x coordinate, y coordinate and this is the z coordinate. Combining these three will give a single point on the curve. Now let me take an example to illustrate the Bezier curve. Here I have taken the three control points and I have made the z coordinate 0, so that in a two-dimensional the curve will become a two-dimensional curve and it will be easier to understand. Therefore z coordinate I made it to 0. Therefore you can see the first x coordinate of the first control point, you can see the subscript I put 0 and x, this is the x coordinate and this is the 2. And in the similarly next control points, x coordinate is 7, next is 12. In the similarly y, I made it to 3 and 14 and 3, and all the z coordinates are all 0. Next we'll take for u equal to 0.1, what happens, let us see. For u equal to 0.1, here you can see this is the you can say formulas for finding the x coordinate of that x coordinate of the point on the curve, and for particular value of u 0.1, and we substitute that all these values of, and here n equal to 2. Why n equal to 2? Because we have taken three control points, and n will be lesser than 1 from the control. That means 3 minus 1. N will be 3 minus 1. Therefore, it is 2. Therefore, we just substitute, and already I told we are taking u equal to 0.1 and therefore substituting that, and we'll substitute here. We'll substitute here p naught x and p1x, all the x coordinate of the control points, and that in the next I'll show you. Therefore, already we have seen this is the 2, 7 and 12. After that, we found that the corresponding values, corresponding x coordinate for u equal to 0.1 we found to be 3. Exactly in the similar way we can find for y coordinate of the y coordinate also for u equal to 0.1, and that formula is that already we have shown in the earlier cases, and we just substituted that value here. Blending function will remain the same, but the y coordinate will remain, will change here. Therefore, y coordinates, you can see here, it was already I shown in the previous that it is 3, 14 and 3, and we if we calculate, you'll find 4.98. In that way, we are calculating that x coordinate and y coordinate, and because z coordinates already I told you it is 0, therefore z coordinate will be 0. Therefore you can see the for u equal to 0.1, the x coordinate is 3, y coordinate is 4.98 and z coordinate is 0. And now I incremented u by 0.1, therefore u will become 0.2, and exactly I discussed in the for previous cases, and exactly in the similarly the u will be substituted as 0.2 and all the things will remain the same. Therefore, in that way we are getting that for 0.2, the x coordinate, corresponding x coordinate on the curve is 4, and the y coordinate is found to be 6.52, and z coordinate already I told you 0. Exactly in the same way, now we'll take the u value, will change it to 0.3, and then we'll find it out, and x coordinate will be found to be 5, and the y coordinate is found to be 7.62, and z coordinate is already 0. And in that way we found out all these values corresponding to 0.1, 0.2 for u values, and therefore I am showing all the calculation here. Now it is a 0.4. I incremented by u by 0.1, and the corresponding value of x is 6, and then the corresponding value of y is 8.28, and z corresponding value of z is 0. And now I am taking 0.5. Here x coordinate is 7, and corresponding y coordinate is 8.5, z coordinate is 0, and corresponding to 0.6, it is x coordinate is 8 and y coordinate is 8.28 and z coordinate is 0, and corresponding to 0.7, it is x coordinate is 9 and y coordinate is 7.62 and z coordinate is 0, and 0.8, you can say x coordinate is 10 and y coordinate is 6.52. You can see now y coordinate is reducing, anyhow that will show in the curve, and z coordinate is 0, and u equal to 9, x coordinate is 11 and y coordinate is 4.98 and z coordinate is 0. And we'll summarize this, all the values we calculated, we'll summarize on the table. You can see for the different value of u, whatever the values of x coordinate and y coordinate, we got it. And if we plot the x coordinate, y coordinate as a point, then we get the curve that I'll show in the curve. Now you can see on the table that corresponding value of u equal to 0.1, we got x coordinate as 3 and y coordinate 4.98. That all in details how we found out, we have shown in the previous. And then we summarized here all this, and then we plot this in a graph. We plot it. Here you can see we are plotting that this is the u equal to 0.1, corresponding u equal to 0.1, that is 3 and approximately 5, and that is corresponding to u equal to 0.2, u equal to 0.3. In that way, all these values we found out, we plotted it, and then we join it with this smooth hand. If we join, then we get the exact Bezier curve, and that is all about the Bezier curve.